Hello all, I am Professor Neelam Bhosale from NAVSHYADRI Education Society Group of Institutions. Welcome all for a workshop on Basic of Engineering Mathematics. We are going to discuss about or learn about rules for a differentiation. Objective: to differentiate function using the power rule, constant multiple rule, and sum and difference rule. The derivative is used to find the slope of a function at a point. The derivative is used to find the slope of the tangent line to the graph of a function at a point. The derivative is used to find instantaneous rate of a change of a function at a point. The derivative is computed by finding the limit of a difference question as a delta x approaches to 0, that is the definition of limit. There are several number of notations for a derivative. First notation is f dash of x. Second notation is the y dash. Third notation is the dy by dx. It means apply the derivative of y with respect to x. Rules for a differentiation. Differentiation is the process of computing the derivative of a function. You may be asked to differentiate, derive, find the derivative of. Rules for a differentiation. First rule, the power rule. Power rule is d by dx of x raised to n is equal to n into x raised to n minus 1. N is any real number. First example on a power rule. Differentiate x with respect to x. That is d by dx of x. When I compare this example with our power rule, here value of capital N is 1. So substitute 1 in our power rule. So you will get the derivative of x is 1. Second example of power rule. Differentiate f of x is equal to x cube. Apply the derivative on both sides. Derivative of f of x is the f dash of x. And apply derivative on x cube. Using the power rule, derivative of x cube is 3 into x square. Here value of capital N is 3. Second example, y is equal to x raised to 9. Here, apply the derivative on both sides. Derivative of y is the dy by dx is equal to, apply the derivative of on x raised to 9. So derivative of x raised to 9 is 9 into x raised to 8. Here capital N, value of capital N is 9. Third example, g of x is equal to x raised to 100. Here value of capital N is the 100. Apply the derivative on both sides. Derivative of g of x is the g dash of x, and derivative of x raised to 100 is the 100 x raised to 100 minus 1, that is 99. Second rule, the constant rule. C is the constant here, and apply the derivative on C, derivative with respect to x. Everyone knows that the derivative of constant function is always 0. So here derivative of C with respect to x is 0. Example on a constant rule. Find the derivative of f of x is equal to 7. Apply derivative on both sides. So derivative of f of x is the f dash of x, and 7 is the constant. Derivative of constant function is the 0. So f dash of x is equal to 0. Second example, y is equal to minus 3. Apply derivative on both sides. Derivative of y is the dy by dx, and derivative of minus 3 with respect to x is 0, because minus 3 is the constant and derivative of constant function is the 0. Another notation for dy by dx is what? Y dash. So we called as a y dash is equal to 0 also. Next rule, the constant multiple rule. You can see that here, apply the derivative with respect to x on c into f of x. C is the constant and f of x is the any kind of function. So when I apply derivative with respect to x on c into f of x, c outside and apply the derivative on f of x. So derivative of f of x with respect to x is the f dash of x. So in short, constant multiple rule is what? D by dx of c into f of x is equal to c into f dash of x. C is the any constant. So we get one note. Note is The derivative of a constant times a function is equal to the constant times the derivative of the function. Example on constant multiple rule. First example, find the derivative of y is equal to 2 into x raised to 1 by 3. Apply the derivative on both sides. So y is equal to 2 into x raised to 1 by 3. Derivative of y is the dy by dx. 2 is the constant, 2 outside, and apply derivative on x raised to 1 by 3. Using the power rule, here value of capital N is the 1 by 3. So derivative of x raised to 1 by 3 is 1 by 3 into x raised to minus 2 by 3. Here power of x is the negative now. So negative power, that's why x raised to minus 2 by 3 taken denominator. So dy by dx is equal to 2 divided by 3x raised to 2 by 3. Okay, don't forget it. Here value of capital N is the 1 by 3. Here we have to use the power rule. Constant multiple rule. Again example, find the derivative of g of x is equal to 5 into x raised to 7. Apply derivative on both sides. F g of x, its derivative is g dash of x, and phi is the constant, phi take outside. Apply derivative on x raised to 7. Again using the power rule, x raised to 7 its derivative is 7x raised to 6, and 7 into 5 is the 35. 35x raised to 6. Final answer is g dash of x is equal to 35x raised to 6. Next rule, the sum and difference rule. First is the sum rule. Apply derivative on f of x plus g of x. It means we have a two function f of x and g of x. Add these two functions and apply derivative with respect to x on it. When I apply, then derivative goes separately. That is, derivative of f of x with respect to x is f dash of x, and derivative of g of x with respect to x is the g dash of x. We get one note, the derivative of a sum of a derivative. Second, differentiation rule. We have a two function f of x and g of x. Subtract these two functions and apply derivative on it. So d by dx of f of x minus g of x is equal to f dash of x minus g dash of x. So we have a note here, the derivative of a difference is the difference of the derivatives. Example on sum and difference rule. First example, differentiate f of x is equal to 5x square plus 7x minus 6. Our first step is what? Apply derivative on both sides. So derivative of f of x is the f dash of x. Okay. Now apply the derivative on 5x square plus 7x minus 6 using sum and difference rule. First of all, apply the derivative on 5x square. 5 is the constant, 5 take outside. Apply derivative on x square. Using the power rule, x square its derivative is the 2x. 2x into 5 is the 10x. So derivative of 5x square is the 10x. Middle sign is the plus as it is. Now 7x. 7x its derivative. 7 is the constant again. Take outside, and derivative of x is the 1. So final answer of 7x, derivative of 7x is the 7. And last number is the minus 6. Minus 6 is the constant value, and derivative of constant function is always 0. So minus 6 is derivative is 0. So derivative of f of x is equal to 5x square plus 7x minus 6. Its differentiation is f dash of x is equal to 10x plus 7. Second problem, g of x is equal to 4x raised to 6 minus 3x raised to 5 minus 10x square plus 5x plus 16. Step number 1 is what? Apply derivative on both sides. So g of x is derivative is g dash of x. Apply derivative on 4x raised to 6. 4 is the constant. 4 take outside. X raised to 6 is derivative. X raised to 6 is derivative using the power rule. 6 x raised to 5. 6 into 4 is the 24. So derivative of 4x raised to 6 is 24x raised to 5. Middle sign is minus. Keep as it is. Now derivative of 3x raised to 5. 3 is the outside. Now apply derivative on x raised to 5. Derivative of x raised to 5 is what? 5x raised to 4. And 5 into 3 is the 15. 15x raised to 4. Now minus. 10x square its derivative. 10 as it is. Apply derivative on x square. Derivative of x square using the power rule is the 2x. So 2 into 10 is the 20x plus 5x its derivative. 5 as it is because 5 is the constant term, and apply the derivative on x. Derivative of x is the one everyone knows. So 5x its derivative is the 5. And last number is the 16. 16 its derivative always 0 because 16 is the constant number. So derivative of g of x is what? G dash of x is equal to 24x raised to 5 minus 15x raised to 4 minus 20x plus 5. Let's see some more example and how to solve the differentiation, previous procedure of the differentiation. There are 4 sessions. First one, function is given f of x is equal to 5 divided by 2x cube. Okay, 5 by 2 is the constant. Before applying the derivative, 5 by 2 take outside and remaining term is 1 upon x cube. 1 upon x cube shift in numerator. It looks like f of x is equal to 5 by 2 as it is, and x cube is shift in numerator, that it looks like x raised to minus 3. Now find the derivative or apply the derivative on both sides. F of x is derivative f dash of x. 5 by 2 is outside, and x raised to minus 3 its derivative using the power rule, minus 3x raised to minus 4. Using the multiplication of these two constant term, 5 by 2 into minus 3 is the minus 15 divided by 2 x raised to minus 4. And x raised to minus 4 again shift in numerator, so it will be x raised to 4. So f dash of x is equal to minus 15 divided by 2 x raised to 4. Second problem. Given function g of x is equal to 7 divided by 3x x raised to minus 2. Now again, before applying the derivative, we have to simplify this. 7 by 3 take outside, and x raised to minus 3 shift in numerator. And it looks like g of x is equal to 7 by 3 into x square. And now apply derivative on both sides. That is the g of x is derivative g dash of x. 7 by 3 is outside, and apply derivative on x square using the power rule. X square its derivative is the 2x. And 7 by 3 into 2, that is 14 divided by 3x. This is the derivative of g of x. Now third example. Given function h of x is equal to root x. Everyone knows that root x is nothing but the x raised to 1 by 2. So rewrite this. H of x is equal to x raised to 1 by 2. And apply derivative on both sides. H of x is derivative h dash of x, and x raised to 1 by 2, its derivative is 1 by 2 as it is, using the power rule, 1 by 2 into x raised to minus 1 by 2. And minus 1 by 2 is in power of x is the minus 1 by 2. This is the negative value. So x raised to 1 by 2 shift in denominator. So it looks like h dash of x is equal to 1 by 2 x raised to 1 by 2. This is the simplification. Thank you.